this computer. Okay, I'm gonna go over the last year's exam. And then if you guys have any question, you can stay and ask, and then maybe we can do the problem together. But other than that, I don't have anything specifically planned it except the Monopoly part. But yeah, that's not something I'm supposed to share. Okay. So is that okay with everyone?
Yep, sounds good.
Okay, wonderful. Okay, so this is the last year's exam, and let's just go through it together. So number one, suppose you are a rice farmer. You harvest 300 units of rice in the spring, and this income is to be allocated across 2 time periods, right? One's during the spring and one's during the fall. So spring will be X1 and fall will be X2. Once you decide how much to consume in the spring, the rest of your harvest save for the fall. But due to the poor storage techniques, half of this saved amount will get destroyed. So X2 equals 1/2, 300 minus 1. Regarding this, you will get your budget's constraint of that. Okay, so let's do the setup. So the setup would be your budget equals to X1 plus 2X2 equals 300. So this question is kind of like similar to period of consumption things that maybe you guys went through in class where you have a whole year of salary and then you have to make the decision of saving and consumption. So it's like a consumption saving problem. So if there is a bank that is offering you like interest rate, like would you consume more this year or would you save more and consume next year? So it depends on the interest rate ratio, right? So if they all like the bank offering you a lot of interest rate by you saving into the bank, you might save more during period 1 and consume more in period 2. So it's a similar problem. So in this case, the period 2 would be in the fall and the rice will all get damaged. Okay, so A. Okay, a clearly labeled figure shows your budget line and initial endowment. Okay, this is okay. So this is period 1 and this is period 2. So if I consume everything on period 1, I can consume 300. So if I consume everything in period 2, how much I can consume? So I consume 0 on period 1 and then plus 2x2 equals 300. My x2 is equals to 150. So if I can save everything in period 1 and then consume in period 2, I will get 150 because half of them will get raw in the storage. Okay, so this will be our budget line. B, utility of x1, x2 equals to ln of x1 plus half of ln of x2. Okay, so that this utility it's sort of like a preference. So like as we can see from this like preference, that there is a discount for consumption on period 2. We rather consume more in period 1 than in period 2. How can we see that? We can draw a graph. So we can use a graph of U and then consumption of X1. So our utility as X1 increase, utility like they increase less and less. Okay, so this is ln of x1. I'll change the color. Maybe x2. So what about x2? X2 would be the same, but less than consumption now, right? So I do not want to consume. Well, no, I mean not like do not want, but I dislike to consume in the future. I want to consume now. So that half is kind of like acting as like a future discount thing. Okay. So did I answer this question by just saying that? Okay, so let's see the question. Hi, in any period, how does your utility respond as you consume more? So each period, if you consume more, your utility is increase less, right? And two, how would you evaluate spring consumption versus fall consumption? And as I draw it here, exactly half. You value fall consumption half as good as consumption in period one. Okay. Does this make sense? A little bit?
Andrew, I have a quick question.
Yes.
For 1A, the initial endowment, it's at 0.300, correct?
Huh?
For question 1A, so where it says to like label the initial endowment, that's at 300, correct?
Initial endowment. Yeah, this is 300. This is
Okay.
150.
Okay, got it. Thank you.
So like if the storage facility is completely safe, then like my consumption will look supposed to be a straight line. It's supposed to be look like that, right? So it's kind of like, yeah. But
Okay, thank you.
if there's like interest rate with me save more at this period and then I can consume more in the future, then my budget line will look like this. I don't know if you guys gonna have that type of problem, but I just want to like point it out because that will be in behavior. Everything in behavior will be something like this. So 300. Who how? 1 plus R over 300. So R is your interest rate that you save in period one, and then the more that you get from that interest rate, it will be that budget. That's right. Okay. Let me see, Nisha, for the problem, well, for the points on x1, x2 intercept on the graph A, can it be done by? I mean, it's exactly that, right? So it's basically this is our budget. Because we know this point right here, we consume 0 unit of x2, so this whole x2 would be just gone. So x1 would be equals to 300. If you try to find this point along the x2 line, then you set x1 equals to 0 because all along this line where x1 is 0, we'll have 2x2 equals 300. So that's how we find the point. Yes, of course. It's just like when like there might be a situation where then that gives you like something more generalized. Yeah. Okay. Any question on the interpretation on B? If not, I'm gonna move forward. We're really tight on time. I don't want to like waste you guys' time to review. Okay. Set up the maximizing problem, then set up the Lagrange maximizing problem. Ooh. Okay. Solve to get your utility maximizing consumption bundle. Show your step clearly. Okay, this is max x1, x2. This is the setup where u of x1 and x2 equals to ln of x1 plus 1/2 of ln of x2. And subject to x1 plus 2x2 equals to 300. So that's our setup. Now we're trying to set it up into Lagrange. ln of x1 plus 1/2 of ln of x2 minus lambda of x1 plus 2x2 minus 300. Okay. So DL, dx1, 1 over x1 minus lambda, DL, dx2. Oh, let me know if I'm going too fast or if you are confused with anything, okay? Just stop me. It's okay. So 1/2 and 1 over x2 minus 2 lambda. And same thing, we're gonna set lambda 2 over lambda 1. So lambda 2 over lambda 1. So okay, so we set this with 0. So we get 1 equals to 1 over 2, 1 over x2 over 1 over x1, which equals to 1 over 2x2 times x1. And we get 1 equals to x1 over 2x2. And x1 equals to 2x2. And x2 equals to 1/2 x1. All right, let me check my notes. Nope, that's false. False. My bad. My bad. But there's a 2 here. So 2, 2. So 2x. I did it too fast. Let me go over again. My bad. So 1/2. And then there's a 2 in this lambda. So it has to divide another half. So this is 2, 1, 4, x2. 1 equals to x1, 4, x2. x1 equals to 4, x2. Yeah. x2 equals to 1/4 x1. Okay. That's that. And then we're gonna plug this into our budget. So our budget looks like x1 plus 2x2 equals to 300. We're plugging x1, 4x2 plus 2x2 equals 300. And x2 equals to 50. And x1 well equals to, so if you have 300, it's 200. Right? So pair 1, I consume 200 units and I save 100 units. When period 2 arrives, that 100 units turn into half because of the poor storage unit. Okay, so that will be our optimum. That's for C. Okay, Did I lose anyone here?
Me a little bit.
Which part? The first order
Uh,
condition?
where'd you get the 4x from?
Oh,
Because
where's
is it from the half 1x over 2 over 1x over 1?
it's from here, right? So we set this
Oh,
equals each
okay.
other. This 2 goes back, and then this becomes 4.
Okay. Now I see it. Thanks.
Any other question? Okay, so let's go back to the graph. Look at this graph. It's not in scale, I guess. Maybe maybe it's in scale. I'm such a good painter. It should be in scale. Okay. So this is 150. So our optimum bundle is 200, right? So between 150, it's probably here. So we probably consider right here. 100. And then we have something like utility, whatever. Okay. So that will be our optimum bundle. Where 200 and 100. That's not 100, that should be 50. I guess it's not in scale. It's okay. Okay, so next question. D. Suppose an entrepreneur set up a lossless storage facility in town. Use that storage technology, there will be no destruction of any amount of set aside for fall consumption. Write your new budget constraint and draw it on a curve for part A. Okay, so let's draw it. We just did. So it's the red line. So this red line, this red line would be D. And write your new budget constraint. So your budget constraint would be 300. Without loss would be x1 plus x2. That will be your new budget.
Andrew, could you just scroll up a little bit? I just want to see the Exxon function. Just down a little bit. Just want to make sure I have the right thing. Down.
Yeah.
So you could do it while go down so you could write and stuff. Okay, yeah, I did the right thing. All right.
Okay, so that will be our new budget because there's no loss. Therefore, the price of consuming in period 1 and period 2 will be the same. However, our preference of consuming now and the future, it's still different, right? Because our utility is still the same. So we still have this discount in the future. We rather consume now rather than consume in the future. Okay, so that will be D and E. But access to new technology comes at a price. Suppose the entrepreneur will keep a fraction A of anything you store in the facility. What is the maximum fraction you would be willing to pay? So this is, let's just look at the graph. So now you have to pay A of 300. And then you set it equals to, well, without the technology, you only have 150, right? So your A must be 1/2. The max amount of ratio you're willing to pay is exactly the same as the shitty storage. The cost of the shitty storage. Does that make sense? So here is after tech innovation. This is before tech innovation. Right? So before, like, you have to set that A ratio of after A ratio of the amount that you can save for period 2, and then set that equals to, oh, what if you have a shitty storage? That will be your max amount of A you are willing to pay for that new technology, right? So if A equals 1/2, that means it costs you, like, the new technology costs you half of the amount that you're gonna storage anyway. Then you are indifferent than the shitty storage you have before. So that will be your max amount of ratio you are willing to pay. Right? Okay. So that's the ratio part. So next few questions, I think it asks about fixed amount. So fixed amount, it's relatively kind of like a cost minimization problem. So we'll go over that shortly, I think, right now. Is it like F? Yeah, F is a fixed amount. Fixed amount of rice R. But E is a fraction, right? Yeah, okay. How about this? Let me just like clean this page up so we can like keep doing problem while looking at the graph. It's easier that way. So, okay. So now you have a fixed amount of rice R. So your fixed amount of rice R would be, okay, you pay one time and then you can access that technology. It's not depends on how many rice you storage. It's a fixed amount. It's not a variable amount. So it will look like your cost function would be x1 plus x2 minus fixed cost, which is R, equals to 300. So that's your new budget, right? So how can we find, let me just read through the question with you guys, with everyone together. Alternatively, suppose you have to pay a fixed amount of rice to access the facility. Set out the problem you will solve to determine the max amount you will be willing to pay to access this technology. Right. So the maximum amount of R. Okay. So let's set up the problem. So this is this problem. So your ratio of the cost function, it didn't change. However, we don't know the R. So we have to line this budget line and trying to match an indifference than the previous utility. Right? Does it make sense? That will be the max amount of R we're willing to pay. So it's this distance. Okay, so I'm gonna write a setup. So it's min of x1 and x2, in which we're moving the budget, right? because the budget is unknown. We have a R inside. We have to pay a fixed amount of R. So x1 plus x2 and subject to our preference, utility of x1 and x2. Okay, so when we find this optimum for x1 and x2, we will plug it into this function, and then we will set R equals to that number, which is 300 minus x1 star and minus x2 star. Does that make sense? So abstractly, it looks like this in the graph. So you know you have to pay a fixed amount of R. You don't know how much. So that you are indifferent than before. Right? So if you are indifferent than before, then you must have the same utility. Right? So we don't know how much we just moved. That's why we need to use minimization problem. Okay, minimization function to try to find that R. And what's our budget?
Can you say that again, please?
Okay. Okay. So are we okay with this budget setup?
Yeah.
That we have to pay a fixed amount of rice to use the technology.
Yeah.
So we will have this R will equals to 300 minus x1 and minus x2. Is that correct?
Mm-hmm.
But we don't know how much we have to change in the consumption of x1 and x2 in order to keep the indifference, which is the utility must be the same.
Wait, isn't that minus R?
Right here.
No, I'm in the equation. Just realize, is it the negative R, so it will go on the opposite side and the opposite side.
Yeah. Okay. Let me just do it real quick. x1 plus x2 minus R equals to 300. And then 300 switch would be x1 plus x2
With the
minus
minus,
300
yeah, instead
equals
of plus.
to R.
Yeah, because I realized you had the signs. Or am I bugging?
Yeah. I mean, x1 plus x2 minus 300 is equals to 300 minus x1 and x2. They're the same.
Okay.
Right. If everything is correct, then they all should be R equals R.
Okay.
Just like the sign change a little bit. Okay, so if we are good with this equation, then we can conclude that this is the case. But we do not know the new optimum bundle that we will staying at the same utility curve. So this minimization is to find that bundle. To find that bundle that cross the old utility curve. Because we have to max, well, I mean, felt like it's confusing. I'm not explaining it like well enough. Did anyone understand this problem? Maybe someone has a better insight and better explanation on this? Anyone? Hmm? Oh my goodness. This. Okay, so this intersection would be 300 minus 12 R. Is that correct? That's not really, that's not true. Yeah, that's true, that's true, that's true. That's true. 300 minus R. And then here, the y-intercept will be 300 minus R. And we don't know that R. In order to get that R, we have to find the optimum bundle for x1 and x2. That lies right here in this red line on the same indifference curve. So we can find this difference in R. Does it conceptually make sense? Hmm. Let me check the answer key. Dun, 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 dun. Okay. So in the answer key, yeah, you get the utility of the original, and then you subject that utility into your new budget. And then you obtain that optimum for x1 and x2, and then you set them equals to R. I don't know how to explain it in words. Okay, I'm struggling. Does it make sense? Or like which part are you like more confused about? Are you like not understanding why we doing the minimization problem? Or are you confused about the R?
No, now I understand the R part and why to do the minimization. So based on what you explained, I figured I get it. I think I get it.
Okay. Yeah. Okay. When it says what rise income will leave you exactly as well off that. Yes, the new optimum for X1 and X2. When the price ratio is 1-to-1, like adopting new technology. And then you have the same utility curve. Yeah. It's not the old price bundle. Okay. Maybe we can move on to next question 2. This F, it's like, I'm tight. I am tight. Okay, let's move to question 2. 2. Consider a producer of a banana who used to inputs according to the following production function. Y equals to F of X1 and X2 equals to X1 1/2 and X2 1/2. A. Is this production function increase return to scale, constant return to scale, or decrease return to scale? It's 1/4. Okay, so the things that we learned from undergrad is that if A alpha plus beta is less than 1, then we have a decreased return to scale. Return to scale. So this is the alpha, this is the beta. But in terms of like, because this is like the perfect Cobbler-Douglas function, that's why we can do that. If this is not, you should test it out. So how can we do that? We can do it by plugging 2, trying to double the amount of X1 and X2. Right? So if I double my X1 and X2, I will have 2X1 to the 1/2 times 2X2 to the 1/4. And then I will have X1 to the 1/2. This 2 becomes square root of 2 times square root of, well, not square root at this point. It's 2 to the 1/4 and X2 to the 1/4, which equals to square root of 2 to the 1/4 y. All right. So before we have X1 and 1/2 and X2 to the 1/4, we will equals to 1 unit of y. So this, if square root of 2 and 2 to the 1/4 is less than 1, we will have decreased return to scale. If square root of 2 to the 2 to the 1/4 is equals to 1, we have a constant return to scale. If square root of 2 to the 2 1/4 is greater than 1, we'll have increase return to scale. Well, we can just generalize using T. Right?
So would we have to solve for it like this?
I think you should use T. But for me, like in terms of like what's the best, like the best way to get it is to put double, right? we know that we like if we double the amount of inputs, we should double the amount of output, right? Does that make sense? Yeah, well, it's not one, it's two. Yeah, it's two. No. If it's one, then it's like it's decreasing return to scale anyway. So we should like double amount of y. So this like 2, because we change it to t, then this 2 should be just t. If we put it generalized. So it is decreased return to scale. So t to the 1/2 to the t to the 1/4 is less than t. So it's decreased return to scale.
Andrew, should we be using this formula to solve for it anytime we're looking for any one of these functions?
You mean increased return to decreased return?
Yeah. Or is it like different? Because
You should, because it's not always Cobb-Douglas.
okay, so if it is Cobb-Douglas, we don't have to use it.
Well, I mean, if it's Cobb-Douglas, we know that there is an easier way to just like look at it, and then we know that this is not like this is increased return or constant return or decreased return, right? I don't know
Okay.
how much proof that he wants. Maybe he wants you to show all the steps, right? So I think it's better for you to know how to use the T and generalize things a little bit for all type of function. So okay, so we have to kind of like explain. We can explain using marginal utility. Well, not marginal utility, marginal product of x1 x2. Well, x1 and then marginal product of x2. No, x1. Yeah. This is marginal productivity. So as you increase the units of x1 and x2, your production output actually decrease. So if you double the amount, then it doesn't give you double amount of work. Okay. So B, suppose the price of the input are W1 and W2. In the short run, input 2 is fixed at some level x2 equals 9. Then how much of input 1 do you need to produce any output of y? What's the short run cost function of y? Okay. We have x2 equals 9 fixed. Then our preference would be x1 to the 1/2 9 equals 1. E well, 1 equals to 1/2 and 9 x 1 to the negative 1/2. Maybe I should not skip into much. And let's put the budget in. W1 and W2. Okay. So W1 X1 plus W2 X2 equals 2. Fine. So we have to find. We know that X2 is 9 units. So our budget looks like this. 9 equals 1. And now we only have X1 is unknown, and we have this function right here as our production function. So X1 to the 1/2 equals to Y divided by 9. And then we can square root it. Oh, not square root it. Square it. Square it. So X1, the decision of how many labor we put it in is Y squared divided by 9 squared. And let's just plug it in. W1 equals to Y to the square divided by 9 squared plus W2 to the 9 equals to Y. Because our capital is fixed at 9, our cost function would be C of Y equals to W1 Y squared 1/81 plus W2 to the 9. Okay. So that's for the cost function.
Why you have 1/8(1)?
Hmm?
Oh, the square root of, oh, no
81.
worries. I'm bugging.
Yeah. Because this is a short run. Short run decision. Run cost function. Okay, so now we're going to see. Suppose the price of banana is P. Solve for the firm's short run profit maximization problem to derive supply curve of Y as P and graph it. Okay, so we know that in order for firms to maximize profit, we must have marginal cost equals to price. So CY must equals to P, which equals to W1 Y. Ooh, I haven't taken the derivative yet, so we have to take a derivative. With respect to Y, we will get 2W1 1/81 plus 0. This will become fixed cost. So our marginal cost.
You left one of the Y.
Oh yeah. Yeah. Thank you. Let me check something. Like I'm bugging. Oh. Did I do something wrong? Oh, I see the problem. This is 1/4. My bad. So 1/4 is 2/4. So this will be, it's not, my bad, my bad. Oof. Oh, yeah, this is still not. That's still not, but this is not. This is 9 to the 2/4. Sorry. So 9 to the 2/4, that's not 81. That's 1/3. Because it's the 9 to the 1/2 is equals to 9 square root, which equals to 3. Like, where's that 94, 81 come from? No. So like I miss the beta on the machinery. So the machinery should have a beta of 1/4. Not bad. Okay. So we found our marginal costs of production of additional unit of production. That will be 2W1 1/3 Y. And we're trying to find everything which is supply on Y equals 2. So Y is right here. So we have a P divided by 2 W1 3P 2 W1. That's it. So that's our supply. And when we graph it, 20. So when we have a price increase, what happened to our supply? Increase, right? So we'll have a normal supply curve of YS equals to 3P of 2W1. Okay. If we have to find the slope, how can we do that? We just inverse the function. Let's not like inverse, but so P. Oh, it's right here. Okay, this is our slope of supply. But this is the function, supply function. Okay. Any question on that? How to find the marginal cost and the supply function? Did I lose anyone? Okay. Okay, D. Suppose the price input 2 raise sharply. Input 2. Is it X2? X2. So suppose that input 2 raise sharply. Will the firm's short run supply curve change? Explain intuitively. Okay, so let's see, we have our cost function of Y right here equals to W1 X1 plus W2 X2. Right, this is fixed. And C of Y equals to W1 I made a mistake. Oh. 1/3 Y to the square plus W2x to the fixed. So our marginal cost with respect to y, it's only this in the short run, right? Because in the long run, everything here will be fixed. So this W2, no matter how much your W2 increase, like it won't change anything on our marginal cost function. So no, this is two, right? Our marginal cost function only depends on price of W1, which is the labor in the short run. So for D, if you raise sharply, so will it be. It doesn't matter because short run supply function only cares about labor. Does that make sense? Wouldn't that be CY not Y? Which part? Hmm? 702. That's not long ago. Could you say something, Sumiya? Which part? Okay. Are we good on D? And price of machinery increase, it wouldn't necessarily affect our short run supply function. Because our short run supply function, we only care about W1. And also the number of output that we produce. Because our marginal cost is basically the marginal productivity of labor. Because machinery is fixed, it drop out. There's nothing we can do. It's a fixed cost. It doesn't vary on our output. But in the long run, it will. It will definitely contribute to our long run production decision. Okay. Let's go over E. Suppose there were negative externality associated with banana production. Explain why free market equilibrium might not be efficient. So this is like kind of like open question on the negative externality. So if there is a negative externality, what happened to the market? So let's see, we have market equilibrium. With demand, we have a supply, and we have price, and we have supply. So negative externality associated with production of banana, right? So that means that when we plant banana trees, it actually start to kill the land or something. Or maybe the fertilizer we use for banana farming, it's very costly for the environment, etc., etc., etc. So in that case, market cost is actually lower than social cost. Cost. So the optimum production should be lower, and then price should be higher because there's externality. So I guess in this question on the exam, like, or the type of the question, you just have to kind of like explain intuitively what those like externality were and how can those affects the sort of like supply and demand, and yeah, that's pretty much it for E. Okay, do we have other question that we can go over it together, or any other question regarding to this final exam? Yes, it is. So if you look at question 1, that's from the first half of the semester. It's a utility. So you should probably get used to finding utility and labor decision and consumption decision, right? So like, for example, the type of question that he really likes to ask is like, assume that you have a number of hours of week, like number T hours of week to do whatever you want. And then you have to make the decision between whether or not you want to like relax or buy stuff, right? So you have to find the sort of the budget with given situation. So it'd be like, so T number of hours in a week. And then you have to make a decision of between relax and consumption. Some utility. So your budget should be, so when you're making a decision whether or not to relax or consume, you have to make the decision that of a certain amount of labor that you want to put in within the week. So your total number of hours a week, you can either spend all that time into working, you will get WT. So W of labor plus W over relax will equals to WT. So whatever you make from labor, you will use all that to consume, which will be price and number of consumption. So PC plus WR will give you like the total amount of WT. Does that make sense? Like, I think he loves to give out this type of question. And also the maximization, minimization, those you guys should be really familiar by now. And as well as I don't think he will put too much weight on monopoly and perfect competitive market. So let me like kind of like go over this monopoly market and like why the graph looks like the graph it looks last week on his post video. So I believe monopoly looks like this, PQ, and then you have marginal revenue, and you have demand, and you have marginal cost, right? So this is something that what monopoly looks like. Your decision, like your profit maximization point should be MC equals to MR. And when it is like monopoly, you actually have like larger amount of surplus. So in that case, the monopoly has price setting power. And there won't be any competition to absorb the marginal revenue. Right, because in monopoly, we only have one firms or like a few firms that it's within the industry. So you're gonna profit maximize by MR and like equals to MC, and then you're gonna set this Q units by the price of the market demand. Right. So when a monopoly market slowly become less costly for other firm to entry, your demand, the market demand for your like or the original monopoly, it's gonna decrease because that demand so as time goes on, the demand actually are gonna cross the point of your marginal cost, because like other company are taking those consumer away from you, so you cannot like set the price as you wish. Does that make sense? And your marginal revenue will go down as well, along with your well, so that deep blue line is your your market demand. So like your marginal revenue like start to shrink, or like your marginal revenue just become the demand. Yeah. So I mean that's the kind of like confusion I was like sitting through that recording from Professor Basu, like because I'm not sure how, like why is that marginal revenue exactly half of the demand? Like what if that monopoly market slowly become competitive? Like how is that transition to competitive market is going to be? So that's that for the competitive for monopoly. But I don't think I have anything else. But
Do you have like an actual monopoly question we could look at?
actual monopoly question?
Yeah.
I think.
But he didn't really dwell on it, so I'm not even sure if we should stress about it, because it's just that last class he did it in, I think. Yeah, right? It was just that last class, right, guys? I don't think he talked about it much.
Yeah, it was only just that last class.
Okay.
But he made mention that he might not bring questions on Monopoly because we didn't have much revision on it, or we didn't go much into it. But you can never get to tell with him sometimes.
Yeah.
Yeah, I don't
Yeah.
think Monopoly would be. If it would be just like one tiny small question that is more asking you about the concept of Monopoly. Probably you don't need to solve anything.
Yeah.
But yeah, that's for that.
Okay, thank you.
Yeah. Do you guys have any other question or maybe a big question you want me to go through? Oh, number 3, it's the insurance premium thing. You guys haven't learned it yet, I think. So that question is canceled. I mean, the topic is canceled. But if you're taking behavior, that insurance premium, it's gonna come up on behavior. Okay. Yeah, I made a few mistakes. Sorry.
When we draw the graph, Andrew, how do we know if it's X1 or X2 is the endowment one? It's gonna be the one with the more?
What do you mean on the
Like
budget?
in question 1A, so like how the endowment was X1 with a 300.
Oh,
Did
we
it
just said endowment.
on the answer sheet he provided, you said the 300 would be it.
Yeah, like the question it points out that you have harvest 300 units of rice, right?
Mm-hmm.
So imagine that today you want a jackpot of like $300,000. So like that will be your decision. You have to make a decision whether or
Okay.
not like consume all that 300,000 today, or you can save it for tomorrow in the future,
Okay.
right? So
Okay.
like because this like, well, I can go over again because the broken storage, like your 300,000 like got got invested into like corrupted investment banker, and then it shrank to half or something. I don't know.
Yeah, I got you. Because I was just wondering, so for example, if X2 was not by 2x but just like X2, 1x2, then the endowment would maybe be on oh no, it can't be on X2. Definitely have to be near 1. Yeah, all right, I get it.
Uh,
So the endowment
I have
isn't
a
the whole budget line.
I'm sorry.
The endowment isn't the whole budget line. It's just like the overall sum of it, or what?
The endowment, it's your M, right?
Okay.
Yeah, your income, right?
Okay.
So like, for example, like you can like just think about this, like because this is not an infinite period problem. You will learn that in macro. This is only 2-period model, so it's only like today or tomorrow, right? So your tomorrow can be like a period between 30 years old to 60 years old. Your initial today would be 0 to 30, right?
Mm-hmm.
So like in terms of like one's lifespan, right? So if you have like $300,000, right? Well, like you can make the decision whether or not you want to consume today, which is during the period of, like growing up, like to the age 30, blah, 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 and investment in education, blah, 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 right? So like, it's the decision of 2 period.
Okay.
Ultimately, you can make it into infinite period. For example, like generational model, you can do that. Like, so what's my consumption saving decision of this generation to the future, potentially like forever generation, right? So maybe there is something that the government can do to sort of like like to sort of like control our consumption today to save for future generation. Like for example, planet, like environment, you know, all that kind of stuff. Like those are something more macro that you will touch up on next semester. But yeah, like just think about it like really abstract, like not something too specific.
Okay.
Hi, can
Yeah.
you go over through like a 2A one more time for the IRS, like constant, then CRS or DRS, like how we gonna identify?
Okay, sure. So I'm
Thank you.
gonna go through with like a few things. So let's do utility of x1 and x2 equals to regular coupled Douglas. X2 to the 1/4. And then we have a utility of that it's not something that it's coupled Douglas form. So it would be x1 plus, let's make it easy, x2 to the 1/2. Okay. And then we can do something like u of x1 and x2, something, I don't know, something really weird. X1 squared minus x2, something like this. Like something really weird. So let's try first one. So, oh, not you. My bad, my bad. It's y. It's production. Okay. So our production would be like, let's put in like, let's double our input. So this is our initial, and then let's double it. So this is the when x1 is equals to 2x1, right? To the 1/2, and then 2x2 1/4. And then we have to calculate equals to how many y. Like ideally, like we can just put 2y here. And then we can just like take out the equal sign. We'll just like put a circle here. We don't know, right? So if it's equal, then it's constant return to scale, right? If it's smaller than, well, if it's greater than, then we know it's a increased return to scale. If it's less than, then we know that this is decreased return to scale. So now we can put a circle in there. Okay. Let's see. And then we have so 1/2, so 2 to the 1/2, x1 to the 1/2, and then multiplied by 2 to the 1/4, and x2 to the 1/4. Okay, so let's just keep this two term together. We have 2 to the 1/2, 2 to the 1/4, x1 to the 1/2, x2 to the 1/4. Right? And then let's multiply this term together. We get 2 to the 1/2 times 2 to the 1/4. That's equals to 2 to the 3/4. Right? Okay, so 2 to the 3/4. So 2 to the 3/4 is less than 1. All right, no, less than 2. How many? 2 to the 1. Right? So therefore, 2y must be greater than this term. That's like kind of like my like very naive way of like treating this type of question. So if you like want to do like a very formulatively, you should put in t and then compare t. So to do that, you can just like, okay, so y to the x1 and x2 equals to x1 1/2, x2 to the 1/4, and then you multiply by t. So t of y of tx1 tx2 equals to tx1 over 1 2 x2 or t to the 1. x to 1/4. And then what you get is t of y, the whole thing equals to t to the 3/4 of some x1 to the 1/2 and x2 to the 1/4. And then t is greater than t to the 3/4, then therefore this is a decreased return scale. Okay. Okay, let's do the next one. Let me just move this to somewhere. So this is the same thing. Let's just this time straight up using t. This I think I'm getting used to it. So equals to t of x1 plus t of x2 over 1/2. So t of y equals to, well, t of x1 plus t to the 1/2 to the x2 to the 1/2. So let's get the t out. I guess this time, like if you put in number, it's easier. This is so much easier if you put in number because you can actually calculate it. So y, 2y equals to, yeah, I guess the 2 is not that easy to calculate either. Anyway, so this is a marginal product of x1 is 1, right? Equals 1. And the marginal product of x2 is less than 1. And that would be yeah, this is actually increased return to scale. Yep, this is where the t method actually goes away. So we have 1. This is x1, and x2 looks like this. x1, x2. Let's draw a line. So let's add x1 and x2. It's probably gonna look like this, or something. That's not true. If I add this up, what will I get? No. This will look like this. I guess I don't know. But this is this equation is increased return to scale. How can I do this? I guess plug in numbers. Yeah. Maybe plug in numbers will be better. Okay, so let's actually try plug in numbers because I just personally don't like generalized equation. Okay, so y of x1 would be equals to 1 and 1 equals to 1 plus 1 to the 1/2. Now we have a y to the 2 equals to 2 plus 2 to the 1/2. So our y, originally we can produce y equals to 2. And then now we can produce y to the 2 plus square root of 2. So it's not equals to 4, which is less than 4. So therefore, this is decreased return to scale. Okay. Okay. Well, ultimately, I solve it. But no, I still don't know how to use t. But if you plug in real number, you can actually solve it.
So in the exam time, like if there is a explanation or anything, so we can put the number and like solve this way.
Yeah, because you like literally you double.
Okay.
Right? You double every your input. You're supposed to get double the output, right? So the first output is 2. And you're supposed to get 4. And you get less than 4. So that means, yeah, it must be decreased return to scale.
Okay, got it. Thank you.
Sorry, I'm not good at generalized equation. Okay. So let's look at the super weird one, which is y of x1 and x2 equals to x squared minus x to the 1/2. I think that's what I wrote. No, it didn't even have. Okay, so we have this.
No, it's fine. Thank
Okay, 1 goes to minus 0. Y of 2, 2. So this is 2, 4 minus 1. Y of 4, 4. 16 minus 4. So 3.
It should be 4 minus 2.
No, 4. I double the input of the labor and capital. This is x2. It's minus 4. Oh, you mean this?
No, yeah, that one.
Okay, good catch. Okay. So this is increase return to scale. Okay, use number. Use number. Use a number. Number is way better. Like for me, the number is the only one that I can consistently rely on. In the exam, like if you know how to work with number, just work with number. It will save you a lot of time and then confusion. Okay. Any other question?
Do you have any additional tips other than that? I don't think. Seems like nobody is asking.
No, if nobody asking additional tip, if nobody asking like, so like, I mean, like strong suggestion would be like, try to graph them. Like if you can see the graph, it's better to interpret it using the graph. And if you can draw a table, if you can like list out like the actual double, like, you know, those makes logical sense, instead of like all the confusion. But yeah, like, I guess it's just like read the question. I'll have a good suggestion. And then like maybe go through it one more time with the Lagrange.
Yeah.
And make sure you know how to take the derivative of ln and take the derivative of the exponent stuff. I think you should be okay.
Okay.
Yeah, I mean, if nobody have a question, I'm gonna try to go over minimization problem. Well, no, not minimization problem. It's the minimum preference, which is like the perfect complement question.
Okay.
Yeah. So if you want to leave, you can. If you have a question, you can still stay and ask. But Good luck on the exam. I'm gonna keep recording, just in case. Let me find the perfect complement question, and then we can go over it. What problem set is that? Problem set 5. Oh, it's problem set 5. Nope. Yeah, it's okay. I guess we will go over. If you stay, I'm gonna go over 2021's exam. Yeah. Okay. Okay. Should I start from the beginning or should I just what should I do? Let me start from the beginning. Okay, so this is the final exam for 2021. So there's like more question we can maybe practice with. Okay. So let's read through the question together, go through it. Just step by step, question 1 to all the way question 3 maybe. Okay, 1. Let's do the setup. And let me read first. Nina has 10 hours available each day, and she can use these hours to consume bread or relaxation. Suppose that price of the bread is P and an hourly wage rate of labor is W. Her utility function is U bread relax equals bread relax. Okay, so setup is U equals to B times R. And we have 10 hours available. 10 equals N. Okay. So A. What's her budget constraint? Don't worry about the dollarization. So her budget constraint would be 10 times wages will be equals to if she spent everything. Oh, maybe I should not use 10. Let me just like use time. Generalize it. It's 10. It's like pretty confusing. So total time that she can spend on work, either work or relax, times wage, what equals to the time that she spent on work, which is labor, plus the time she spent on relax. So in this budget constraint, the money that she earned from doing the labor, which is like she could use for consumption, which will equals to price times bread. So the consumption would be price of the bread times quantity of the bread. Imagine that the bread is the only thing that she consumes. So her budget would be P times B plus W, and relax equals to WT. B. Write out the Nina's utility maximizing problem and then associate with the Lagrange function. So max is just a normal setup of bread and relax. And then we have a utility of bread and relax. And subject to price of bread plus wage of relax equals to wage of T. T is the total time that she's available each day. So that's it for B. And then C, solve for Lagrange. So Lagrange equals to B times R, utility minus lambda of P times B plus W times R minus WT. And we have a DL, DB equals to R minus P times lambda, DL dr equals to B minus W of lambda. And then we have 1, we have 2, set them equals to 0, lambda 2 over lambda 1 equals to 1, which equals to B divided by W over R divided by P, which also equals to B divided by W times price over R. And let's find the ratio. Well, we got the ratio already. And then we just need to isolate and then find the B star. B star would be equals to WR over P. Yeah. So you multiply by WR, you divide by P. And then your decision for consuming relax will equals to okay. And then when you find the ratio, you can just plug right back into your budget constraint to find B star of price and wages, and then R star for price and wages. So that's the demand function for bread. And then this is the demand function for relax. So we have the ratio, now we plug back in, then we get our demand function. So P times B plus W times R. So the R is equals to BP over W. W cancel out equals to WT. And then we have a 2 BP equals to WT. Isolate B, we get B star equals to WT over 2P. So that's our demand for bread. And demand for relax is P times our B equals to WR over P plus W times R equals to WT. P cancel out, we get 2WR equals to WT. W cancel out, we get R star demand equals to T over 2. Okay, did I lose anyone from all this going through? With a setup on the budget and then with a Lagrange and finding the demand for bread and finding the demand for relax. Or did I make any mistake? I don't think so. Okay. Okay, I'm gonna keep going. We are short on time. I don't want this to be like 3-hour video. C, D. But if you have a question, please ask me. Yeah. D, this utility function is Cobb-Douglas. As you know, the property of Cobb-Douglas utility function is that the consumer allocate fixed proportion of their income into each goods based on the relative value of the exponents on B and R in the utility function. Explain how the demand function derived for part C satisfy this property. So part C is demand for bread equals to that WT over 2P, and our demand function is equals to T over 2. Okay, so as we can see from here, let's check my bio. Am I doing correctly? All right, guys, I'm just checking my answer if it's correct. I don't want to like have the wrong thing. Okay. Yeah. Okay. So we can plug in this T. We get RD equals to 10 over 2. So our R, demand for relax, must be equals to 5, right? So this demand function, no matter how much we change in the price ratio, we have to consume half of what we have for relax. So B of D is equals to 10. Well, I mean, let's not do 10 minus 5, but if we plug it in, it's W of 10 over 2P. Think about this. Makes sense. So the amount of bread that we can consume, it depends on the price ratio of wages and the price of the bread, right? So we have 5 units left from like our everyday hours availability. So we have 5 hours left because we must consume half of our total available time into relax. So the rest will be the amount that we can consume for bread. So yep. So I guess like explain how would be that the demand function for relax, it's fixed. It's always half of our of total hours available. So therefore, it kind of like satisfied the Cobbler-Douglas, which is 1-to-1 ratio, right? So our bread times relax equals to utility. So this is like 1-to-1. So we're gonna like split our hour in half, 1 for labor, and whatever we make from labor, we use it for consumption, and 1 portion is for relax. Okay, so that's for D. And we can go to 2. 2 is the thing. Yeah. Okay. Consider a firm that produces a bread using 2 inputs. So a firm of bread using 2 inputs. What inputs are you using? Let me see. Labor and machine. Okay, so min. Min. Then I'll square root of L and machine. And price of labor equals to wage. Price of machine equals 1. So 8. Oh, a clearly labeled graph. No need to make to scale. Draw isoquant associated with output level 1, 2, and 3. So in this case, we have level 1, level 2, level 3. Y1, Y3, Y2, Y1. I think my brain starts shutting down. Okay. Is production function decrease return to scale, constant return to scale, or increase return to scale? So as we said in earlier, we can just plug in the number and we can just try it out. So let's put in y of combination of labor and capital equals to 1 and 1, 4 and 4, and A and A. So minimum of square root of 1 to 1, and this gives us 1. Minimum of square root of 4 to 4, it gives us 2. Of square root of 8 to 8 equals to square root of 8. Okay, so as we can see, if we quadruple our input, we get only double of the output. Y equals Y equals Y. So we only have like double of the output. And if we like next step, we double again, we get less than double of our output. All right, 2 is 4. So it's only square root of 2. So this is how you know you have decreased return to scale. You can put in T, you can try. But yeah, and you don't have to cover either situation, so it should be okay. So let's go see. Solve the long run cost minimization problem for any level of output B. What are the cost minimizing level of L and M? Let's write down. Okay, can someone like talk to me? I'm getting bored on the question.
Hi.
Andrew.
Are you guys still here?
Yes.
Oh, here.
I'm so bored. Okay. Okay. So let's look at C. Solve for a long run cost minimization problem for any level of output B. So we want to produce a level of B. Right, so level output of bread. What's the marginal cost function of B? And your answer will define all of it. So let's look at the cost function of B fish. So we know that when we have this like what is this called? Perfect complement? Oh, perfect. Yes. Yes, perfect complement. Perfect complement. Yes. Equals to square root of L equals to M. Right? So B is equals to square root of L equals to M. So B must equals to square root of L. B must equals to M. So in this case, in terms of L star, so L star, we will have B squared. And in terms of M star, so M star must equals to B. So in this case, let's construct our cost function. So cost function of Y will equals to wage of labor plus wage 2 of M, right? And then C of Y, we know that our cost for machinery is 1. So we have 1M. Now let's substitute all the L and M in terms of B, production level of B. So C of B is equals to W B squared plus B. All right, so this will be our total cost function. So this question is also asking about what's your marginal cost function. So your marginal cost function will just take the derivative with respect to B. So you have 2W B plus 1. That's it. And C. Any question? Okay, great. Okay, let's keep going. Okay, E. This firm has an increased marginal cost function. So we can solve for the profit maximizing supply decision for the firm. Okay, yes, we know that because what? So every unit of B, we are increasing our marginal cost increase, right? So we know our marginal cost is increasing throughout. The more we produce, the additional units for bread, it's going to cost more. Okay. So we can solve this for I'll produce until marginal equal. Okay, so marginal cost equals to P. That's our profit maximization. Okay. So profit max. So we have a max. Max profit. Let me just double check. Max profit. That
Yeah, it's
sound
asking
wrong,
for to
right?
solve for.
Yeah.
Mm-hmm.
Okay. So like my brain's like literally not working. I don't know why. I think it's too late. Or just like lack of sleep. But, okay, so we need to find a supply function for B. We have set it up already. And then we just need to find B star.
There's a question, Andrew.
Mhm.
It's in the chat.
Let me see the chat. Wait, but in part B, didn't we say decrease return to scale? Yeah, it's decrease return to scale, right? So decrease return to scale means what? So the more input we put it in, the less output it come out, right? So that's decrease return to scale, right? So decrease return to scale and increase marginal cost, it's two different things. Well, I mean, it's not really two different things, but if you have increased marginal costs throughout in like every unit, when you increase to infinity, then you must have decreased return to scale. Oh, okay. See, late night. I don't think anybody can do well in late night. Okay, let's just finish this. So P minus 1 over 2W. So that will be our supply side, production side decision of producing unit of bread. It depends on price of the bread divided by wages. That's it. That's it for E. Let's do number 3. In this problem, we'll combine problem 1 and 2. Let's make the extreme assumption that Nina and the firm are the only two entities in this economy. Okay, so we only have labor supply of Nina, and we only have, like, just think about it, like there's just one person, which is Nina, and then there's one firm, which is the firm that produced bread. Let's call it like Bread Inc. or something, whatever. So as a labor, you have to participate in labor in order to have the wages to buy the stuff for your consumption, right? So like this market supply for labor and the market demand for labor, they are like very close intertwined with each other. They depend on each other, right? So if our consumption decrease as a like consumer, then will happen to firms, production firms. If we're consuming less, then the firm is producing less, then they are gonna cut wages, and then there's like infinite loophole for recession. Okay, so that's question 3. Let's just assume there's only 2 entities. One's supply for labor and one's demand for labor. Okay. Okay, perfectly competitive. Okay, great. Okay, A. 1C gives you demand curve for bread, and 2E gives you the supply curve for the bread. Okay, let's look at demand for bread. 1C. So B equals to WR divided by P. Is that true? That is true. No, that's not true. What am I talking about? No, this is demand. Okay. WT divided by 2P. Which we know that we have a 10 units of T. And then 2 whatever. So they get cancel out. We got 5 W over P. And then we have, this is demand. We have B of supply, which equals to P minus 1 over 2W. Okay, we have some demand and supply. And I think this is just, we just set it equals to each other. Oh, we have to draw it? Okay. Fine. So this will look like I'm slowly losing my mind. Bread. This is price of bread. So let's draw a supply curve, right? So how do we draw a supply curve? We just isolate P. So P equals to 2WB minus 1 plus 1. Slope positive. Positive 2W. So this is BS. BS. Okay, let's find demand. So demand, let's isolate P. Divided by P, multiplied by P. So P times B equals to 5W. So 5W over, am I crazy? This is supposed to be negative. Oh, my fault. Wait, no, not my fault. P equals, P equals to, we'll just swap it up. And we got 5W divided by B. So as B increase, P decrease. Yeah, makes sense. Right? Yeah, it makes sense, right? As P, no, as B increase, quantity of B increase, P decrease. Right? So if B equals 1, then P equals 5W. If B equals infinity, then P equals to 0. Yeah. Great. Wonderful. So the demand probably look like this rather than like straight line, but it doesn't matter because the question you don't have to draw as super perfectly. Blah, blah, blah. Okay. E. Any question on that?
Yeah.
Yeah.
Oh, somebody was talking.
What's the question?
Oh, I was gonna ask. So you didn't use the demand, the 5. Okay, okay. No, I got it. I got it. It's
Right.
okay.
Yeah, it's not relaxed. It's bread. Okay, so we go with A. This is the COVID exam. It's super easy. My mind is like not working. Setup and then simplify the condition to solve the equilibrium price for the bread. Okay. It will be messy. Okay, so we don't have to do it completely, but we know that the equilibrium P must equals to each other and B, S, and D must equals to each other. So we just set them equals to each other. So WT over 2P equals to P minus 1 over 2W. Okay, so we can cancel out the W. And then what we have is 5 P. Oh, whoa. 5 1 over P because T equals 10, right? Equals to P minus 1 over 2. I think that's it. That's it. Like I can try to simplify it, but 5 equals to I mean maybe like divide by 2, then here to become 10. 10 equals to P minus 1 or multiplied by P. So 10 is equals to P squared minus P. So if you set it equal to 0, so P squared minus P minus 10, it's gonna be super messy. So we're not gonna solve it. So this should be sufficient, or this should be sufficient. Okay. So that's for B. Let's go for C. Okay. The answer to part B depends on W. Whoa. It does? Am I crazy? Okay. Let me just check myself if I go too far. Yeah. Did it wrong. Did it wrong. This whole thing is wrong. I okay. Sorry. My math is like start to not doing well. So please make sure you have enough sleep during the exam. You don't want to like stress out and like start to make like infinite amount of mistake. So 5W over 2P equals to P minus 1 times 2W. So what we have, 2 cancel out, but we have 5W squared equals to P minus 1 over times P. Yeah. That makes more sense. Oh no. This 2 not supposed to be there. It should be 10. I'm making so much mistake right now. Okay. So this 2, this 2 is already canceled out. So 2, 10, it canceled out. So it's 5 and nothing on the bottom. So it should be 10W squared. So yes, it does depend on W. Firm has increased marginal cost function, so we can solve for, well, I'm not reading it. The answer to part B depends on W, but we could use information in the above problem to arrive at the explicit solution for P star. Explain. So we need to find the explicit solution. Okay. Explicit solution. Explicit solution. Explicit solution, is it just like we just plug it in? Hmm. Yeah, we just plug it in this question. Because we need to find the P star. P star in terms of something. But let's take a look at the Okay, I should take that word back. This exam is not easy at all. I was stuck on this question and then don't have time to do 4 and 5. What's the function? What's the function? That's so familiar. We know how much we will produce. It doesn't matter. Yeah, it matters. Maybe we should look at the function for labor and production function. Okay. So, production function. File B equals to square root of L equals to n. So b equals to square root of l. B equals to l. Square root of l equals to, well, l equals to b squared. So we know from our labor supply. We know this from the consumption and relax decision, which is consumption and labor decision. Labor. We know that L equals to 5. And we know that L equals to 5, and we know B squared. So B squared is our production function that we just found. So P minus 1 divided by 2W squared. Okay, sound like something. Let's see. 5 equals to P minus 1 divided by 4W squared. What's going on? What here? Well, no. So our budget, marginal cost equals to P. So P equals to 2WB plus 1. B equals to, yeah. Yeah, I think this is the explicit function. And then we're trying to solve it. So 5 divided by times 4, W squared equals to P minus 1. Ooh, hoo, 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 hoo. Okay, this is the question that I will probably just like give up. But yeah, if you really want to try to solve this question, I can send you the key. I don't even understand this key. But yeah, other than that, I think that I'll be done for tonight. Any other question?
Thank you so much, Andrew.
Yeah, thanks, Andrew, for the whole semester.
Yes, you've been great, a great help to us. I'm not gonna lie.
We've stressed you a lot.
I hope it helps.
You deserve a raise.
Oh, okay, I'm okay. yeah, just good luck on the exam and yeah, yeah, happy holiday, and I'll see you guys next semester.
Yes.
Thank you.
Thank
Fingers
you.
crossed.
Bye.
Thank you. Have a good night. Get some rest.
Bye.
Good night.
Oh, send us
Thank
the
you, good night.
the answer sheet, please.
Yeah, just email me.
Okay.
All right, take care.
Bye-bye.
Bye.
Thank you. Bye.